Okay, so we'll start with Q. T is not a direct neighbor of Q, so Q will never receive information from T. So we know that that will be blank all the way through. First iteration, don't have information from R or S either. And then we just fill in the distances to Q's adjacent neighbors, which are R and S. That's 2 and 8, so 0. And then to R, it's 2. And then to S, it's 8. And we don't know to T. Okay, now for, we'll do R next. R is neighbors with everybody, but right now it doesn't know, so it only knows itself. R to Q is 2, R to itself is 0, R to S is 4, R to T is 10. Okay, and next S. S to Q is 8, S to R is 4, S to itself is 0, S to T is 3. And then T is not adjacent to Q, so we will never have a row for Q. Right now we don't know about R and S, so T is to Q, T does not know how to get to Q, T to R is 10, T to S is 3, T to itself is 0. Now everybody sends their distance vectors to their adjacent neighbors, so Q sends to R and S, so 0 to 8 dash, 0 to 8 dash. R sends to everybody, so 2, 0, 4, 10. It skips itself. 2, 0, 4, 10. 2, 0, 4, 10. S sends to everybody 8, 4, 0, 3. And T sends only to R and S, dash 10, 3, 0. Okay, so for Q, never going to be smaller than 0. To R, we're not going to get smaller than 2, so we don't need to check that. Now to get to S, well, let's see. If Q goes through R, if Q goes through R, it takes 2 to get to R, and R takes 4 to get to S, so 2 plus 4 is 6. Does that make sense from our graph? Q to S to 4. Yes, that makes sense from the graph. Okay, to T, well, we can go through either R or S. So to get to R costs 2, and from R to T is 10, so that would be 12. S to T is 3. To get to S is 8. 8 plus 3 is 11. 11 is smaller. Okay. Now we'll go to R. R to Q, that's 2. Not going to get smaller than that. R to itself is 0. 4, only possibility would be to go through T, but it costs 10 to get to T in the first place, so that'll stay 4. To get to T right now is 10. What if we go through S? Okay. To get to T through S, from S to T is 3. To get to S in the first place is 4. 4 plus 3 is 7. Does that make sense here? To go from R to T, 4 plus 3 is 7. That does make sense. Okay. Now S. Okay, to get to Q, well, what happens if we go through R? So we're starting at S, and to go through R, it costs us 4 to get to R, and from R it costs 2 to get to Q. 4 plus 2 is 6, which is less than 8. Okay, now to get from S to R, would it be cheaper to go through Q? Well, let's see. How much does it cost to get to Q? 8. So no, that would not be cheaper. S to itself is 0. Is there a cheaper way to get to t? No. Okay, now for t, to get to q, we can go through either r or s. To get to r in the first place costs 10. 10 plus 2 is 12. To get to q from s is 8, but to get to s is 3. 3 plus 8 is 11. 11 is less than 12, so I'll put that there. Except that was that the right? Yeah, that's the right spot. Okay, now from t to r we currently have 10. What if we went through s? Okay, well, to get to r from s is 4, and to get to s is 3. 3 plus 4 is 7, which is less than 10, so we'll put that there. S is 3, okay, not going to get less than that, and 0 to itself. Okay, did the q's distance vector change? It did, so it will send that to everybody. Well, not to t, because it's not a neighbor of t. Okay, did r's distance vector change? Yes, so it'll send that out. Did s's distance vector change? Yes, it did, so it will send that out. And did t's vector change? Yes, it did, so it will send that one to everybody except for q. Okay, so now let's check q. Okay, 0, not going to get smaller than that. 2, not going to get smaller than that. 6, let's see, so that's if we go to r first, that costs 4, and to get to r costs 2, so that's 6. Okay, t, let's take a look at s. So to get to t from s costs 3, but it costs us, oh well, no, we're trying to get to t, so that's 11. What if we go through r? To get to r costs 10, and then from r to t, so that's not going to change, so that's 11. Except it's not 11, what did I do wrong? Hold on. Let's try this again. So, from r to t, from r to get to t from r is 7. To get to r in the first place is 2. 2 plus 7 is 9. That's the right answer. Okay, so 2 are not going to get smaller than that, and 0, and 4, is that going to get smaller? No. And 7, well, let's see. Let's check s. So, to get to t from s costs 3, and how much does it cost us to get to s? It costs us 4. 4 plus, okay, so that's the same. That's still 7. Alright, 6. Okay, what if we go through r? I think, so to get to q, if we go through r, it costs us 2 to go from r to q. And how much does it cost us to get to r in the first place? It should cost us 4. I don't know why I have 2 here. I don't know what I did there. I don't know what I did there. It cost us 4, and so that would be 6. Let's see, is there any way this is going to be less than 4? I don't see any way. 0, not possible to be less than 3. And I don't know how I filled this in already. I should not have. This was a disaster. But I don't want to go back and do it. Let's see. So, to get to Q, currently costs 11. If I go to S, to get from S to Q costs 6. And to get to Q in the first place costs 8. So that would be 14. That's not less. To get to Q from R costs 2. And to get to R costs 7. 2 plus 7 is 9. Okay, so here we have 7. What if we went through S? So to get to R from S is 2. How much does it cost us to get to S? Do I still, oh, I had that 2 there again. I have it up here. Oh, because I don't. Oh, because I had it wrong here, so it would be wrong everywhere. Okay. Okay, so to get to R from S costs 4, but to get to S costs 3. 4 plus 3 is 7. That's what we have. 3, that's not going to get smaller, and 0, that's not going to get smaller. Did any of the vectors change? They did. But I'm not going to run through it again. If you run through it again, you will see that nothing changes, so this is the end.